Hello everyone. In this tutorial, we are going to provide a solution to this interesting exponential equation 8 raised to the power of x minus 2 raised to the power of x divided by 4 raised to the power of x minus 2 raised to the power of x equal to 17. And we are looking for the real value or values of x that can satisfy this equation. Before we start, I would like to remind you something about equivalent fractions. If you have a fraction, for instance 1 divided by 2, whatever number you use to multiply or divide the numerator will be exactly the same number to multiply or divide the denominator, and the fraction remain equivalent. So we are going to apply the same principle here. I would like to divide the top and the bottom by 2 to the power of x. So let's do that. The top is 8 raised to the power of x minus 2 raised to the power of x. The whole of this, I would like to divide it by 2 raised to the power of x. You equally do the same thing to the numerator, which is 4 to the power of x minus 2 to the power of x. Also divide by 2 to the power of x. The fraction will remain equivalent, and this remain equal to 17. Now we are going to split the fractions because we have 2 terms here. Divide by a single term, so you can write it as 8 to the power of x divided by 2 to the power of x, then minus 2 to the power of x divided by 2 to the power of x. All right. So this is 8 to the power of x divided by 2 to the power of x minus 2 to the power of x divided by 2 to the power of x. That is the top. The bottom, you do the same thing. 4 to the power of x divided by 2 to the power of x minus 2 to the power of x divided by 2 to the power of x, and this remain equal to 17. All right, another law of indices you should remember is whenever you have, for instance, let me say 5 to the power of 2 divided by 3 to the power of 2, you can see they have the same exponent 2, 2. So you can always express it as 5 divided by that 3, the basis, then assign a single exponent 2. So you're going to do the same thing here. We have 8 divided by 2 raised to the power of a single exponent x minus, but these two are exactly the same. If they divide, you get 1. You divide, you equally do the same thing here. 4 over 2 raised to the power of x minus 1, and this is equal to 17. We are moving. 8 divided by 2 is 4. So we have 4 to the power of x minus 1 divided by 4 divided by 2 is 2. We have 2 to the power of x minus 1. This remain equal to 17. All right. You can see we have 2 here. This is 4. We can express it as 2, right? 2 to the power of 2 is the same thing as 4. So instead of 4, we are going to write it as 2 to the power of 2. But we still have an x, so they will multiply, right? Or you can bring it outside. Minus 1 divided by 2 to the power of x minus 1. This is equal to 17. And from here, you can switch this exponent. Is allowed in one of the laws of indices. You can write it as 2 to the power of x, then to the power of 2 minus 1. But this one can also be written as 1 squared divided by 2 to the power of x minus 1. This is equal to 17. To the top, we have difference of 2 squares. What can you remember about difference of 2 squares? You take the first term without power, which is 2 to the power of x. You minus the second term without power. Then you multiply again. You take the first term without power. You add the second term without power of 2. Divide by 2 to the power of x minus 1. This is equal to 17. So you can confidently cancel this and this because they are exactly the same. What we have to the top is just 2 to the power of x plus 1. To the bottom we have 1, and if you divide by 1, nothing will change. This is equal to 17. If you take 1 to the other side, it becomes negative. You have 2 to the power of x equal to 17 minus 1, which is 16. So 2 to the power of x equal to 16. But 16 is the same thing as 2 to the power of 4, right? So this is 2 to the power of x equal to 2 to the power of 4. Having the same basis, we can equate the exponents. And this implies that x is equal to 4. This is our final answer, but if you like, You can test it in the main equation to see whether you're going to get 17 or not. Thank you for watching. Do share to your learning colleagues. And don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.